Question is related to FSM, finite state machine. So the given diagram related to different states S0, S1, S2. This S0, S1, S2 represent the different states. So the states in FSM is represented with S0, S1 and S2, different states. And there are A and B are the strings. I think these are binary numbers, 1 or 0s. In the question, identify the statement that are correctly describes the given finite state machine. So all the options consist of, except all the strings have even number, odd number of A's and even number of B's and odd number of B's. Okay. In general, FSM, what are the different states? So in FSM, there are 4 types of states are possible. So first one is initial state. So initial state does not handle any inputs. So initial state does not handle any inputs. There are 0 number of A's and 0 number of B's. So the initial state is represented with arrow in the where the finite state machine begins the execution. And it does not handle any inputs. So it does not handle any inputs. That is no inputs. Finite state machine always has only one initial state, only one S0. That is the only one initial state, start state. It is represented with arrow, right? So this one arrow, it is represented with direction arrow. So in this given finite FSM diagram, what is the initial state? Okay, S0 is the initial state. And the next state is accepting state, or final or terminal state. So that is terminal state. Only this state in FSM accepts the strings, input strings. That is the final state only accept the input strings. Can do the computation or text match. 0 1 0 1. This is input string is processed completely successfully, means only it accepted, valid or accepted by this final state or terminal state. Okay, initial state, right? Only one S0. Very important, you can remember this point. Only one initial state. It must be only one initial state in FSM. But in terminal state or final states are 0 final states. If we have 0 final states, 1 or multiple finite states are also possible. Diagram, how we represent the final or terminal or accepting state is with double circle, right? Here S0 is also a initial state and the final state is represented with double circle. There are many final state, terminal states and accepting states. If the string is accepted by the FSM only by the final state, not by initial state, other states, intermediate states, not a non-accepting or intermediate states are transition or process the input strings and change. The transition means change from one state to another state, right? And transitions means changing from one state to another state, that is process the input strings. These are intermediate states. So this intermediate state does not accept any strings. This only process the inputs. For example, if the any input string struck or stops at this intermediate state, this input is considered as a invalid and rejected. So for example, string A means if we start at S0, right? if the string only one odd number of a, that is we will change the transition the state from S0 to S1. So we only ends at the stops at this S1 only. S1 is non-accepting state, intermediate state. So this is invalid state. So invalid state only when we reach the S0. So a, for example another a, we will reach the S0, right? That is even number of a's will reach the S0. Why? The terminal state and initial state both are same. So S0 equal to, so end state start state both are same. The FSM, it accepts the valid strings. In dead state, dead or trap state, dead or non-accepting, it does not accept any strings or inputs, it does not accept any strings, non-accepting state, and there is no escape, that is loop. So in this state only you are reaching. For example, S is a state. In this state, if the input is A or B, both, if the input is A, you will reach here. If the input is B, you will reach here. This is the trap state. It is the non-accepting state. The FSM finite state machine enters into this dead or trap state. Whatever the input may be, the state transitions may trap or loop back into the same state. Only dead or trap state only loops. That is, for example, infinite loop, for example while loop, like that only triggers in that state only, same state, triggers to the same state. So this dead or trap state is useful to handle the invalid inputs, to handle the invalid or unexpected inputs. I think errors, you can handle the errors by using this dead or trap states. State is also possible. The state 5 state is unreachable states, that is unreachable states. So the state exists in FSM diagram, that is FSM finite state machine. So but never actually be reached. So for the example, never reached this state in FSM diagram. The input may be any type of string. So since you cannot reach that state, unreachable states, some states are possible in finite state machine, so which are not reachable by what type of input you have given also. So these are also multiple states. Dead or trap states are more than one state. All these are more than one states are possible. Only the initial state is only one. We will go for one by one option. The first one, option 1. So in the option 1, it accepts all the strings that have only odd number of A's. For example, odd number of A's, 1A. If we consider 1A or 3A's also. Okay. So we initial state and final state. So both are S0. That is the correct answer. So it does not S0. Okay. First we start here S0. So next at the start state A. So the first bit is A, right? So bit string A, we will reach the state 2. Okay. State 2, that is S1. After another A, right? After another A, we will reach back to S0. Okay. S0. Here S0, this is the S1. After another A, we will reach finally for odd number of A's. The final state is, terminal state is, so we started at, for the option A, both are same, right? S0, S1. That is the start state and end state both are similar, only the answer is correct. So this sequence is incorrect. We start at S0 initial state and we reach the state S1. S1 is not a final state. It does not accepting any strings. Only it is a intermediate state. So it does not accept any strings. So this option is incorrect. It accepts all the strings that have only even number of A's. Option B, we consider 2 A's. That is, we start at S0, that is initial net. We want to reach this condition only correct. So at the start state is S0. For the bit A, we reached S1. So for this S1, for the next A, we reached S0, right? S0. So both are same. So this option is correct. Option B is correct. And option C, for this option C, it accepts all the strings that have even number of A's and even number of B's. Even number of A's and even number of B's. Okay. For this state, we start at S0. So for 1A, we reached the S1. And again A, we reached the S0. S1, S0, and B, from S0 to B, we reached S2, and again B, right? Again B, we reached the same state, S2 only. So we reached the final S2. So this is a trap state. That is loop. If the input A or B, anything, it will reach the same state, trap state. So this option is incorrect. And option D is, it accepts all the strings that have even number of A's and odd number of B's. Even number of A's and odd number of B's also. We started at S0. We started at the S0. So here for 1A, we reached S1, right? S1. After another A, we reached S0, state S0. For next bit is B, we reached S2. So we reached S2. So if both are similar only, option is correct. D is also incorrect. Friends, if you like my videos, please like and subscribe my channel. Thank you for watching.